In this next video, I want to go over vertical asymptotes. The line x equal a is a vertical asymptote of the graph of a function f if f of x is increasing or decreasing as x approaches some value a. So here you can take a look at a graph of an example. The vertical asymptote is the dotted line in red, and that is the value that your function is approaching. So my actual function is the two black curves. And so as we are approaching from the right hand side, so as my x value travels from positive infinity towards the x value 2, my function is actually increasing and going up to positive infinity. Now, from the left-hand side, so from negative infinity, traveling until I again approach x equals 2, this time my graph is going down and I'm approaching negative infinity. So this is a picture, again, of a vertical asymptote. You'll often see me abbreviate and call this VA. Alright, so if I'm given an expression, how do we calculate this vertical asymptote? And now this is different than domain. This time we simplify our function and set its denominator equal to 0. So recall, domain, don't simplify. However, vertical asymptote, we will simplify. Let's take a look at some examples. Example A. F of x is equal to x over x squared minus 4. So again, I'm going to simplify this function. On the bottom, I see difference of squares. This is going to become x minus 2 times x plus 2. Alright, this particular function has two items in the denominator, so there'll be two vertical asymptotes for this problem. So set each expression equal to 0 and solve for x. Adding 2 to the other side, I get x equals positive 2. Subtracting 2 to the other side, I get x equals negative 2. So again, this problem has two VAs. And remember to make sure you write your VA as an equation of a line. It should always say x equals some number. So for part A, x equals 2 and x equals negative 2. Let's try example B. F of x is equal to x plus 2 over x squared minus 4. Again, let's simplify this. I have difference of squares at the bottom. That's going to become x minus 2 times x plus 2. This time, I see I can cancel, right? I can take x plus 2 and x plus 2, cancel that out, and I'm left with 1 over x minus 2. Setting what's left to the denominator equal to 0. Adding 2 to both sides, I get x equals positive 2. So this example only has one VA at x equals 2. Now this item that canceled out has a name, and that means it has a hole in the graph. So at x plus 2, when I set that equal to 0, x equals negative 2. Just as a side note, this means that there's a hole in the graph when you go and draw it. Alright, let's take a look at one more example, part C. F of x is equal to x plus 3 over x squared plus 4. Alright, this one's a little tricky, kind of a trick question on this one. X squared plus 4 is not difference of squares, and this cannot be factored. Now, because of the square term, no matter what number of x I plug in, when I square it, it's going to become positive, and then I'm going to add 4 to it. So this particular problem actually has no zeros. And therefore, this particular problem has no vertical asymptote, so no VA for this example. So just to recap one more time, Your function may have one vertical asymptote, it may have two, it may have none. And so sometimes also your VA may be related to your domain and sometimes it may not. So just remember, take your simplified functions denominator and set it equal to 0 to find your VA, which should be an equation of the line in the form x equals a value.